Hi there. Thought we would jump into the Unit 5, Lesson 2 on matrix multiplication. So you can follow along in the reading guide, although I want to make sure you are going to be using the Desmos matrix calculator as well. So when we get there, I'll show you the web address you'll need for that. We'll put it in your notes so that you have it as well. Let's go ahead and jump in. We've got multiplication of a matrix by a scalar, and let's fill in this word is a commutative. That simply means whether you multiply the number, scalar is just a number, whether you multiply a number times a matrix or you do a matrix times a number. Did you catch the difference in the order there? A number times a matrix or a matrix times a number, you're going to get the same answer. So we'll look at how we do that kind of multiplication first, and then we'll jump into how do we multiply two matrices together. So let's take a look here at scalar multiplication. You've got some properties here, and I always feel like properties are best explained through an example. So I'm going to show you through this example how I can do scalar multiplication. This one I'm actually going to do by hand, although I could use the Desmos matrix calculator. And I don't know why, but I want to say matrix calendar, but matrix calculator. So let's do that first. We're going to do this one by hand, as I said. So notice my notation. I'm doing 2a minus 5b. So I'm going to do 2 times matrix A. And then I'm going to do minus 5 times matrix B. Now, I don't want to use the word distributive property, although it's kind of the same thing where I'm going to distribute this 2. This 2 is going to be multiplied times every element in matrix A. So I'm going to multiply each of the elements by 2. So 2 times 3, that will give me 6. 2 times 6, that will give me 12. 2 times 1. You get the idea. I'm going to multiply every element by the scalar, the number that's in front. 2 times 4 gives me 8. 2 times -2 is -4. 2 times 0 is 0. Now we'll do the same for the 5. You'll notice I'm going to leave it as a subtraction, although I could have done it as plus -5 and then distributed a -5. I'm just going to do it as distribute the 5 and then I'll subtract. So I've got 5 times -3, which is -15. 5 times 2, which is 10. 5 times -1, which is -5. Then I've got 5 times 1, which is 5. 5 times -4, which is -20. 5 times 5, which is 25. Okay, so that's how I multiplied by the scalars. Then, next, let's go ahead and subtract. Now, if you remember from our previous video, when we subtract, order matters, so we have to be very careful. I'm going to do an added step for my notes. I'm going to actually write the subtraction first and not just do it in my head. So I've got 6 minus -15. Remember, when we subtract corresponding elements. That simply means that I'm going to subtract the elements that are in the same location. So I did these two. Let's do these two. Order matters. So 12 comes first, minus 10. Then I've got 2 minus -5. And again, you can tell with the negatives going on that I'm being very careful to get the order right. 8 minus 5. I was thinking that answer is 3. -4 minus -20. And then 0 minus 25. Those subtractions, I just want to take my time and make sure I don't make any mistakes with those negatives. So I'm going to go through, change these minus to a plus by changing the sign of the next number, especially with these negatives going on. Super careful. And then let's go ahead and add or subtract depending on what we have left there. So this will give me 6 plus 15 gives me 21. 12 minus 10 is 2. 2 plus 5 is 7. 8 minus 5 is 3. Negative 4 plus 20 is 16. 0 minus 25 is negative 25. Now remember, I was taking my time. I wrote an extra step for the subtraction because I want to make sure I got the order right. You don't necessarily have to do that. If you're comfortable doing that minus a negative in your head, you can most certainly do that. But don't feel that you have to. If you want to be very deliberate and intentional, writing that extra step is not a bad thing, especially if it helps you get the answer right. All right, friends. So we are now solving a matrix equation. Well, we've stepped up our game here. You may be thinking, wow, how did we go to that? Well, it's really just the same idea as solving the equations that we do normally. So you look at your variable, you see it's being multiplied by 1/2 and being added by this matrix. So in your head, you got to think, I got to do the opposite, right? The opposite of adding a matrix is subtracting a matrix. So we're going to subtract this matrix from both sides. Okay, so I'm going to go ahead and do that here, but I'm going to write them side by side. It's a little bit easier to see my subtraction. Now, for those of you who are not writing that extra step, I'm going to go ahead and do that. So I've got 2 minus 4. 2 minus 4. Then I've got 1 minus negative 3. Then I've got 1 minus 12 and 2 minus 1. All right, let's go ahead and do those subtractions then. As before, I'm changing my minus to a plus by changing the sign of the next number. So that gives me 1/2 x equals 2 minus 4 is negative 2. 1 minus 12 is negative 11. 1 plus 3 is 4. 2 minus 1 is 1. Now, we've got to get this 1/2 off of there. So the opposite of multiplying by 1/2 is to divide by 1/2. But we can take a shortcut because multiplying by 1/2, the opposite of that is also to multiply by 2 over 1. So we're going to multiply by this scalar. Now multiply the matrix by 2. Remember, we said that matrix multiplication is commutative. That means order doesn't matter. Whether you multiply by the 2 in front of the matrix or you multiply by 2 in the back, either one is okay. So let's multiply by 2. Negative 2 times 2 gives me negative 4. 4 times 2 gives me 8. Negative 11 times 2 gives me negative 22. And 1 times 2 gives me 2. And voila, there we have our answer. Now I'm hoping in this problem you can see I really wasn't doing anything more than solving an equation. The same way we would have solved an equation that might have looked something like 1/3 x plus 7 equals 10, right? I used the same steps, right? I would have subtracted the 7. In our case, I subtracted the matrix, right? It's the same idea. It looks a little different when it's with the matrix though. So I hope practice with that, right? Practice makes progress. So you'll see, you'll feel more comfortable with it if you practice with a few of them. Okay, matrix multiplication, fun. So for this one, this is where I'm gonna use the Desmos matrix calculator. So I'm gonna put in my notes here the web address for the Desmos matrix calculator. Okay, it's a really nice, robust calculator tool that we can use to help us with these matrix multiplication. just to get us ready, I want you to know that how I'm going to set this up in the calculator is I'm going to have to name the matrices. So I'm going to name the first matrix A, and I'm going to name the second matrix B. And because the order does matter when you multiply matrices, then I'm going to have to do A times B. Just so you know, that's how I'm going to set it up in the calculator. Okay, let's switch over and I'm going to show you, let you see the matrix calculator. So you can see that here. It's a really nice tool, like I said. And so the way we start, we're going to start with new matrix. And you'll notice it chose the name A for this matrix. So we're just going to type in the elements. So 1, and then use your right arrow to go to the next element, 0. Use your right arrow again to go to the next row, 2, right arrow, -3. So you can see, just like I said, I was going to label this first matrix A. Here it is. I've given all of the calculator all of the elements. So let's press enter. And it basically says, okay, we've got that stored. Now let's create the second matrix by clicking new matrix again. This time it calls it B. Very convenient for us. Now in the future, if you need to change the dimensions of the matrix, do that right here. Just increase or decrease the number of rows or columns that you need. This looks pretty good for our B matrix. So we're going to type that in, -3. Again, use your right arrow to go to each of the elements so that you can type them in. And there's my second matrix. Then we'll go ahead and press enter. Calculator says, okay, we got that stored. Now remember, we have to tell it we want to do A times B. So we have to use the matrix notations here. You can't just type capital A. So A times B, and press enter, and the calculator did the multiplication for you. Pretty nice. Now there is a way to actually do this by hand, but for our purposes, you're going to be able to use this matrix calculator for all of your matrix multiplication. So feel free to use it just like we have here. Now I'm going to switch over to my document camera so I can write down my answer to my matrix multiplication. That A times B was -3, 4, and -21, 2. Pretty nice. I like that. So I think I might, for my notes' sake, highlight that web address for that calculator. Definitely want to come back to that and use it again. Okay, let's take a look then. We've got a few rules here at the top about matrix multiplication that you might want to take a look at. They're very useful when you are looking to do matrix multiplication. Okay, and let's look at problem number 4 here. The table summarizes the scoring of a football game between Team A and Team B. A touchdown is worth 6 points. A field goal is worth 3 points. A safety is worth 2 points. And a point after touchdown is worth 1 point. Use matrix multiplication to find the final score. Okay, so we have a pretty good matrix set up here that lets us know what Team A and Team B have done in the game. What I need to do is then write another matrix to multiply by that will give me the points that are assigned to each of these values. So let's think. We know that touchdowns are 6, and that's in column 1. So I want row 1 over here to be 6 points for each team. And then I know that field goals are in column 2. So I'm going to make that in row 2. So field goals are worth 3 points. Then I've got safety is worth 2 points. I'm going to put those in row 3. And then point afters are worth 1. Now this one, we're going to get the opportunity to change some of the dimensions on our calculator when we switch over. Just as a side note, we're going to be calling this matrix C and this matrix D so that we can get our C times D. Okay, let's switch over to our matrix calculator so that you can see that. Oh, let me close that. Makes it a little easier to see. Okay, so let's put in a new matrix. Remember, C here was a 2 rows, 4 columns. So we need to add some columns here. All right, let's type in matrix C, 3, 2, 1, 0. I'm using my right arrow to go to each element. Then I'll press enter. And then we'll have to make a new one for D, right? And D was 4 rows, 2 columns. So we'll type those in. Oops, 3. Remember to use your right arrow as you move through each of the elements. And then we'll tell it we want to do C times D. And we get that the score was 26 to 40, right? 26 to 40. Let me switch back over so that we can see my document camera here. There we are. We got that it was 26 to 40. Now, that is what the calculator gave us, but let's give the actual score. Team A scored, if I can spell, 26 points, and Team B scored 40 points. Very nicely done. See how we let the calculator do that hard work for us? I love that. All right, friends, just one more problem left. We are trying to decide if the product is defined or undefined, and if it's defined, to give the dimensions of the product matrix. So wonderful part of this, we're going to use our good old friend, the calculator, our Desmos matrix calculator, because we're now at, we did A, B, C, D. We know that this first matrix is going to be E, and this one's going to be F. All right, let's take a look. And I'm going to put these in the calculator again. I'm going to try to share it a better way so that, oh, didn't work there again, but that's okay. All right, we're good. Let's put in a new matrix for E. And this matrix is 2 rows and 3 columns. I'm going to type in my elements, again, using that right arrow to get to each location in the matrix. And there's E. There we go. Let's create F. F had 3 rows, but only 1 column. So we'll put in 5, 4, 3. There we go. Again, using that right arrow to get to those elements. Then let's tell the calculator we want E times F. And voila. It tells us that the product's possible. See, the calculator could have given us an error if it wasn't. And so remember, this is possible. And what are the dimensions of the answer was what this question said. Well, I see 2 rows and 1 column. So let's make sure we put that on our calculator, on our reading guide here. So this actually equals -2, 5, and that is a 2 rows by 1 column matrix. All right. Well, thanks so much for your attention. I enjoyed going over this matrix calculator. I really feel like it's a good tool for us. If you want to bookmark it, that would be great. If there's anything else I can help with, I'd be glad to. Feel free to send me a message or leave some comments, and I'll be happy to address those. Bye for now.